All right, this is the second review sheet. We'll call this review C, I guess, for the Chapter 7 Rational Expressions and Functions test. So number 1 says graph y equals 2 over x minus 3. When we do this, the first thing we look for are our asymptotes. Our vertical asymptote is the value that makes the denominator 0. So that would be x equals positive 3. And in this case, this is form 1, right? It's in the a x minus h plus k form. And so our horizontal asymptote is the k, which in this case is 0, because there isn't a k. So y equals 0. And then we'll draw a coordinate plane here. And 1, 2, 3. So we have a vertical asymptote at x equals 3. And our y equals 0 is our x-axis. That's our horizontal asymptote. And then remember, we picked 3 numbers on each side of the vertical asymptote. So I'm going to choose to put in my table. Let's see, that's 2, 1 and 0. Those are my 3 numbers to the left. And then 4, 5, and 6 are my 3 numbers to the right, and my asymptotes between those 2 sets of numbers. So when I plug it in, we're going to plug the number in for x. So y equals, I'm going to work over here in blue, 2 over 2 minus 3. That's 2 over negative 1. So 2, negative 2. Y equals 2 over 1 minus 3, which is 2 over negative 2, which is negative 1. And y equals 2 over 0 minus 3, which is 2 over negative 3, which is negative 2/3. So those points are, let's see, 0, negative 2/3. I put my little green mark on the wrong spot. This is the one I'm using. 0, negative 2/3 is about there. 1, negative 1, and 2, negative 2. So this branch, remember, that gets really close to the asymptotes but doesn't actually touch it. And then I'm going to plug in 4, 5, and 6. 2 over 4 minus 3, that's 2 over 1, which is positive 2. 2 over 5 minus 3, which is 2 over 2, positive 1. And 2 over 6 minus 3, which is 2 over 3, positive 2/3. So we have 4, 2. And remember, when we're graphing these points, we're graphing them onto the coordinate plane. The asymptotes don't change how we plot our points. 5, 1, and 6, 2/3. And we draw our branches really close to the asymptotes, but not touching it. And there is our graph for y equals 2 over x minus 3. If we were to ask for the domain and range, the domain, x such that x cannot equal 3. Oh, that's a really bad curly brace. And the range, y such that y cannot equal 0. So our domain and range are based on our asymptotes, what x cannot equal, and that's what creates those vertical asymptotes and horizontal asymptotes. So number 2 asks which function matches the graph. So we're going to identify what the asymptotes are, and it looks to me like we have a vertical asymptote here. That's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we have a vertical asymptote at x equals 6. And it looks like a horizontal asymptote somewhere in here, about 1. If we look at all of our answer choices, all of our horizontal asymptotes are the ratio of the coefficients. That means all of these horizontal asymptotes are y equals 1. So we don't have to worry about that. So which of these equations has a vertical asymptote of x equals positive 6? Well, A would be positive 5, B would be positive 4, C would be positive 6, and so that's what makes C our answer, and D would be positive 7. So we can find that by just knowing our asymptotes and how to get that from the equation. Similar one, number 3. Again, if you look at all the equations, the ratio of the coefficients for the horizontal asymptote is 1 over 1, so your horizontal asymptote is here at 1, and it's the same for all of them, but where is this vertical asymptote? It looks like it's at 1, 2, 3, 4. X equals negative 4 is my vertical asymptote. My horizontal is y equals 1. So if I look at my equations, this would be negative 3, negative 4, negative 6, and negative 5. So the equation that has the correct vertical asymptote would be x plus 5 over x plus 4. All right, so we're going to look at 4, 5, and 6 on this slide. N squared plus 8n plus 15 divided by n squared minus 25. Simplify the rational expression. Simplify step 1 is almost in every problem is to factor. Okay, you can't start dividing things out unless they're factors. So we're going to factor n squared plus 8n plus 15. What two numbers multiply to 15 and add to positive 8? N plus 5 and n plus 3. And then n squared minus 25 is a difference of squares, n plus 5 and minus 5. So what divides out is our n plus 5s, because n plus 5 divided by n plus 5 equals 1. And your final answer is n plus 3 over n minus 5. Number 5, same thing. I'm going to factor the top. What two numbers multiply to negative 24 and add to positive 2? Let's see, n plus 6 and n minus 4. That adds to positive 2, multiplies to negative 24, and then multiplies to 28 and adds to negative 11 would be negative 7 and negative 4. And then what divides out here is the n minus 4s. So I have n plus 6 over n minus 7. So your answer would be B. Number 6, if I factor, what two numbers multiply to negative 3 and add to negative 2? I have n minus 3 and n plus 1 over n plus 1 and minus 1. Oops, these should be x's. Let's make these x's. Not that it makes a huge difference, but we should be using the correct variable. X squared minus 1 is the difference of squares. X plus 1, x minus 1. It's one of those difference of squares that we sometimes forget about. Okay, so pay close attention. And then the x plus 1s divide out. And we end up with a final answer of, I made it an n again, x minus 3 over x minus 1. And that's your final answer. Okay, we're going to look at 7, 8, and 9 here. Multiply and simplify. So again, we're going to factor x plus 2 squared. We're going to remember that that means x plus 2 times x plus 2. X minus 5 can't be factored. Oops, not equals, times. Times, what can I factor of x squared minus 2x? That's x times x minus 2 over x squared minus 4 is x squared plus, I'm sorry, x plus 2x minus 2. Now we can simplify by dividing out anything vertically. Vertically, So I can cancel these x minus 2's vertically, divide them out vertically, and then I can divide anything out diagonally. Anything horizontal is multiplication. So x minus 2 divides out, and x plus 2 divides out. And what's left is the x, this x plus 2, and the x minus 5. So I'm going to multiply across my numerator. Let's see, we have, I need a pen, x times x plus 2 in the numerator over x minus 5 in the denominator. And that's my final answer. Okay, let's look at number 8. 2x minus 3, that can't be factored. We have x plus 3 times x plus 3, that's what x plus 3 squared means again. And then x squared plus 4x plus 3, that factors to x plus 3 times x plus 1. And 4x squared minus 9 is 2x plus 3. It's a difference of squares, 2x minus 3. We need to be recognizing those difference of squares. Now let's see, what are we going to be able to divide out? Remember, diagonally or vertically we can divide out. So I can divide out the 2x minus 3. I can divide out one of the x plus 3's. And that's it. So what's left is on the numerator, what's left is my x plus 1. And in my denominator, it's going to be the 2x plus 3 times the x plus 3. So that's x plus 1 over x plus 3 times 2x plus 3. Now you don't have to multiply this out if it's a free response, but you might find if this was a multiple choice question, the denominator would be multiplied out for you. So number 9 is a little different because it's not binomials. These are monomial terms. So we treat it more like a problem from chapter 5 where we're just using our exponent rules. So we're going to simplify the numbers first, and then I'm going to multiply across and see what's left. So I see here that 9 goes into 45 5 times, and that 5 goes into 15 3 times. So in my numerator, I have 5xy squared. So I'm going to write that down. 5xy squared in my numerator. And in my denominator, I have 3y. So what divides out here is one of these y's cancels one of those y's. And we end up with 5xy over 3. And that's my final answer.